Hi, Madam Kong. Today we are going to learn about empirical formula and molecular formula. What is empirical formula? Empirical formula is the simplest ratio of all elements in a molecule. And molecular formula is the actual number of atoms of each element in a molecule. So the relationship between molecular formula and empirical formula is molecular formula equal to n empirical formula. We can determine the n value by using relative molecular mass over empirical formula mass. Let's try one example. Question 1. A sample of hydrocarbon contains 85.7% carbon and 14.3% hydrogen by mass. Its molar mass is 56 gram per mole. Determine the empirical formula and molecular formula of the compound. So step number 1, we need to identify the mass of the compound of each element. Over here is carbon and hydrogen. So normally we will assume that 100% is the maximum, so the gram is 100 gram. Then we continue. For step 2, form a table to calculate the number of mole of the compound of each element. So we must know the molar mass of carbon and molar mass of hydrogen. And we need to calculate the simplest ratio by compare with the smallest number of mole of the element. So later we check is carbon or hydrogen. Step number 3, we need to identify the empirical formula based on the simplest ratio. Then step number 4, identify the n value to determine the molecular formula. So now let's check the solution. So as I said just now, we assume mass of hydrocarbon sample is equal to 100 gram. So the mass of carbon is 85.7 gram and the mass of hydrogen is 14.3 gram. So first, this table start with element, carbon and hydrogen, then substitute the mass. Make sure that you write down the unit for mass and also the unit for mole. So 85.7 divided by 12, you get 7.1417. This one not the final answer yet, so make sure it falls any significant value. Okay, same for here, 14.3 divided by 1, so you get 14.3 mole of hydrogen. So we need to find out the simplest ratio. Okay, so this among the mole of carbon and hydrogen, the number of mole of carbon is smaller, so we divide it, so we get number 1, and then this we get 2. Okay, please take note. If the simplest ratio that you get is 1.5, you cannot round off. You must times 2 until you get the whole number. If you get 1.33, you need to times 3, and then you get 4. Get it? Okay, then we continue. So the empirical formula is CH2. Okay, the molar mass given by the question is 56. And then the relative molar mass of CH2 is 12 plus 2 equal to 14. So 56 over 14, we get n equal to 4 by using this formula. So now we times 4 for the empirical formula, and then we get C4H8. Question 2. This question is more difficult compared to just now. So let's study. A 0.5438 gram sample of liquid contains carbon, hydrogen and oxygen, meaning that this compound there are 3 different elements. Burn in pure oxygen, so it's a combustion reaction, and obtain 1.039 gram carbon dioxide and 0.6369 gram of water. So given molar mass is 376 gram per mole, and then the question need to find the empirical and molecular formula. Actually the step still the same, just the step 1 we need to apply other methods to determine the mass of the compound. So we have to calculate the mass by comparing with the percentage of carbon in carbon dioxide and the percentage of hydrogen in water. And then step number 2, form a table as just now. Find the number of mole of the compound of each element and then find the simplest ratio. Okay, by comparing with the smallest number of mole of the element. So this time we check either is carbon, hydrogen or oxygen. Then step number 3, identify the empirical formula based on the simplest ratio. And then the last step, identify the n value. Then only we can determine the molecular formula. So we check the solution for question 2. First, we write down the formula for the combustion reaction. The product is carbon dioxide and water. Okay, so given the mass of carbon dioxide is 1.039 gram, so we times 12 over 44. 12 is referred to the mass of the carbon, and then 44 is the molar mass of carbon dioxide. So we get 0.2834 gram. And then we apply the same thing for mass of hydrogen. So 2 is referred to the mass of hydrogen over here, and then 18 is the molar mass of water. Always remember, must write down the unit, gram. So the mass of oxygen we calculate by using the total mass of the compound minus the mass of carbon and minus the mass of hydrogen. So we get this value. Step 2, form the table. Again, start with element, carbon, hydrogen, oxygen, then the mass with unit gram. Okay, write down the mass of each element, then we find out the number of mole of each element. Now we check which one is the smallest number of mole. So the answer is 0.01185 mole. Mole of oxygen is the smallest, so we have to compare with this smallest number of mole. So after we compare, okay, so carbon is 2. Since this is near to 2, so we no need to round off. Same for here, 5.97 equal to 6, and then oxygen is equal to 1. Then we get the empirical formula C2H6O. Now we need to find out the n value by using the formula that we learned just. So 24 plus 6, 30, okay, 46. 46, n equal to 376. So n equal to 376 over 46. So the answer is 8. So we times 8 with the empirical formula. So we get the answer C16H48O8. So this is the molecular formula answer. Please don't forget to follow my IG, subscribe my YouTube channel, like and share, and follow my Facebook. Hope you all learned something. Thank you.